Welcome to part 3 of logic problems. In this video, we will cover two interesting examples and two practice questions related to the examples. Here are two general techniques in solving logic puzzles. First, we organize the given information using a table or grid whenever possible. Second, we use assumption and deductive reasoning to rule out impossible scenarios or arrive at the correct scenario. We will go through some interesting logic problems, two examples, and two practice questions. Here is example 1. I meet up with an old friend, Daisy, on the street. How old are your three kids? The product of their ages is 36. I still don't know how old they are. The sum of their ages is the house number across the street. I still don't know how old they are. Only my eldest one was born in a leap year. Oh, that's how old they are. How old are the three kids? Pause the video now if you wish to give it a try. Let's look at the solution to example 1. First, let's re-look at the information given. There are three kids. The product of their ages is 36. With this, assuming that the kids' ages are in ascending order, for children A, B, and C, we can construct a table like this. For example, 1, 4, and 9. 1 times 4 times 9 is 36. So this is one of the possible combinations until we reach the last combination, 3, 3, and 4. Out of the 8 combinations, we are not able to determine which is the correct combinations based on the product of 36. Therefore, I'm not able to deduce the ages at this point of time. More information is needed. Next, Daisy said the sum of the ages is the house number across the street. So the sum is mentioned. What we can do is again we construct a table of values for the sum. Okay, example 1 plus 1 plus 36 is 38, so on and so forth until the last row. 3 plus 3 plus 4 is 10. The sum is 10 years. So if the house number is 16, then we will be able to pinpoint the ages. Children A being 1 year old, children B being 3 years old, and C being 12 years old. Because this is the only combination, the sum will be 16 years. So similarly for 38, 21, 14, 11, and 10, if these are the house numbers, we will be able to determine the ages respectively. However, we are told that I'm still unable to determine the ages. Therefore, the house number across the street must be 13. When the sum is 13, there are two possible combinations. Therefore, I'm not able to determine the ages at this point of time, and more information is needed. Therefore, Daisy provided the last piece of information. Only the eldest one was born in a leap year. With this, we will be able to conclude that three children are of age 2, 2, and 9 years old. And the other one, 6, 6 is not the correct combination because 6 and 6, I have two people sharing the same age, which violates the last condition. So the answer is 2, 2, and 9 years, respectively. Did you get the correct answers? Now here is practice 1, which is very similar to example 1. Of course, the scenario changed a little bit, now involving a man and a census taker. but still talking about the 3 children, and the main difference is actually the product of the ages is now 72 instead of 36. All the rest of his information remain the same. Now, can you figure out how old are they? Pause the video now and give it a good try. Here is the solution to practice 1. On the left-hand side is the information presented. Similar to example 1, we can construct a table of values like this. Work out the sum, and based on the sum, 14, when the sum is given, we are still unable to deduce their ages. That means the house number must be 14. With this piece of information, we are unable to determine the ages, and more information is needed. Therefore, the last piece of information helps us to determine the ages of the 3 children are 3, 3, and 8 years old. Did you get the correct answers? Here comes example 2, the famous Cheryl's birthday problem. It is a logic puzzle. The objective is to determine the birthday of Cheryl using a handful of clues given to her friends Albert and Bernard. Written by Dr. Joseph Yo Boon Wai, the question was posted as part of the Singapore and Asian Schools Math Olympiad, or SASMO, in 2015. And this was first posted online by Singapore television presenter Kenneth Kong. It went viral in a matter of days. The Cheryl's birthday problem was covered by many mainstream media, including BBC, CBC, The Independent, The Guardian, The New York Times, and India Today. Here is the question. You may take some time to read the question and try to figure out when Cheryl's birthday is. Pause the video now if you wish to give it a try. Now let's look at the solution to example 2, the Cheryl's birthday problem. As usual, first let's organize the information we have. Okay, these are the month and dates. So basically these are the 10 possible dates given by Cheryl. And we also know Albert knows the month, Bernard knows the day. And these are the conversations between Albert and Bernard in sequence 1, 2, 3, and 4. Now let's go through these lines one by one. First line. Albert says, I don't know Cheryl's birthday. Okay, since Albert knows the month only, so May, June, July, or August, and each of the months actually having either 2 or 3 days corresponding to the month. Apparently, Albert does not know the birthday of Cheryl's. Therefore, the first line is actually redundant. Next, Albert continues, I know Bernard doesn't know too. Okay, Bernard is actually given the day. In the case that if Bernard is given 18 or 19, then Bernard would know the birthday of Cheryl's, either May the 19th or June the 18th. But without knowing Bernard's number, the day, Albert already say he's very sure Bernard doesn't know the dates. So which means Albert is having the month for July and August. He's not holding on May or June. That's why he can be so sure that even Bernard is having 18 or 19, he does not know Cheryl's birthday. Now let's look at line 3 from Bernard. At first I don't know, now I know. So far we already know it can be July or August, and now Bernard is having the number, and Bernard say, at first I don't know, now I know. Suppose that he is having the day of 14. If he's having a 14, then he wouldn't say, now I know, because there are still two choices, July the 14th or August the 14th. Therefore, the number that Bernard is holding on is not 14, and it must be either 15, 16, or 17. Alright, so either July the 16th, August the 15th, or August 17. So this is the information from line 3. And now line 4. Line 4 is from Albert. Albert say, then I also know it. So knowing that the number, the day that Bernard is having is either 15, 16, or 17, Albert said, now I know as well. Then it must be July the 16th. Because if Bernard is having either 15 or 17, and then Albert is not able to determine which day is Cheryl's birthday, because again there are two choices, August 15 or August 17. Therefore, the only choice is that Bernard is having 16 and Albert is having July. In other words, Cheryl's birthday falls on July the 16th. Did you get the answer? Here is the extension of example 2, Cheryl's birthday problem. Most of the information remains the same, except the conversation starts with Bernard. I don't know when Cheryl's birthday is. Followed by Albert, I still don't know when Cheryl's birthday is. And the rest of the conversation is the same as example 2. With this, can you figure out when Cheryl's birthday is? Pause the video now and try to figure out her birthday. Now please allow me to walk you through the solution to practice 2. The table remains the same. Albert is still given the month, Bernard the day. Here is the conversation. Now let's go through line by line. First, Bernard, knowing the day, he said he didn't know. Therefore, we can rule out 18 and 19. Next, Albert, knowing the month, he said he didn't know either. So Albert, knowing the month, so May, check through the row, and June. Okay, at this point, if Albert is having the month of June, then he would conclude it is 17. July, there are 2 dates. August, there are 3 dates. So from this line 2, we can rule out June 17. Next, Bernard said, now I know. Bernard is having the day, so we check through the days. 14, 2 options, 15, 2, 16, 2, and 17 is the only option, 17 August. So now we arrive at birthday for Cheryl, which is August 17. Now we can see actually for line 4, when Bernard said, then I also know it, actually this line is redundant. So the answer is August the 17th. Did you get it? For more logic problems, please scan the QR code below and visit YouTuber Logically Yours. You may also search Logically Yours in YouTube. This is part 3 covering some interesting logic problems. Hope you have learned something. Thank you for watching and stay tuned.